This uniform acceleration concept has introduced a lot of equations really quickly, and I wanted to give you an idea of how to go about solving kinematics problems in an organized fashion. And essentially, what you're going to do is when you approach a problem, you're going to list what you know along with what you're looking for. So, you want to write down the information you know, what you're looking for. So, what's the goal? What are we trying to find? And basically, whatever's left over is going to indicate the equation you want. So, if you look at the four equations we've covered, except for this one, we'll cover that later. You'll notice that each one has a certain variable that's missing. So let's go ahead and list all the variables that are involved here. We have velocity at the end of the time interval, velocity at the beginning of the time interval. We have an acceleration. So these are vectors. Notice we have a time. Delta x, keep in mind that displacement is the change in position. So really that is two different variables, a final position and an initial for the interval. So if we take a look at the average acceleration equation, we can see it can solve for the first four variables. If we look at the second equation here, we can see that as we can solve for position if we know the other one. We can solve for the initial velocity, we can solve for the time and the acceleration. The equation that I'll talk about when we get to energy, notice it has both speeds in it, so we can solve for either one of those. We can solve for an acceleration, but there's no time there. So we can only solve for the displacement. Here we have everything but the acceleration. And that's the secret we're looking at. If we don't care about the final velocity, we're using the second equation. If we don't care about the displacement, we're using the first. If we don't care about the time, we're going to use the third equation. If we don't care about the acceleration, we're going to use the fourth equation here. So let's go ahead and clean up this a little bit, because we don't need all these check marks. It makes it hard to see what we don't care about. So basically when it comes to problem solving, really what you're not looking for and what you don't have, whatever you don't care about, that's the key. What I want you to be aware of, though, is as we learn more and more relationships, I mean, that's essentially what these equations are. That equal sign right there is relating the left half to the right side. When we learn more of these relationships, you're going to start taking one equation and another, or maybe even another, and combining them somehow. So I'm showing you this to kind of help you pick what kinematics equation you want, but this is in no way going to be a method that is going to help you throughout the rest of the course. You're going to have to really think about how things are related and putting things together on your own. So do not rely on this crutch for very long. You're going to have to think about how to relate one thing to another. And that's all I have for you.